Good evening, everybody. Online students, can you hear me? We are starting late due to rain here. It's raining here. Come here, Aj. Bari, come. बाइक से आ रहे हैं तो 45 मिनट्स लग रहे हैं, तो उसी क्रम पे निकल रहा हूँ मैं, तो लेना पड़ा आफ्टर लॉन्ग गैप. अच्छा अच्छा, ऑनलाइन यू हैव अटेंडेड. हाउ वाज ऑनलाइन एक्सपीरियंस? Within the class only. अच्छा, क्लास के बाद डाउट्स कुछ ज्यादा पूछ नहीं रहे हो, तो समझ आ रहा है या समझ नहीं आ रहा है? सब समझ आ, ये डाउट पूछने की हिम्मत नहीं हो रही है क्या? अच्छा, नहीं, एक्चुअल मैं क्या करता हूँ, डाउट्स जो भी आते हैं आपके फेसेस बता देते हैं, तो वो टॉपिक में कवर कर देता हूँ मैं, तो शायद इसलिए नहीं आ रहे होंगे डाउट्स. एनीवे, we were talking about operations on 1D array. We have completed insert, delete, find or set, and along with that I have discussed about put also, that will modify, and then we have discussed about search. In that we have discussed linear search, and one more we have stopped at this binary search. Okay, now we discussed binary search. We found its time complexity. That time also I told you that even floor value or seal value of log is also important. I have shown you that. Some GATE questions are there. He will tell you to give the exact count in which you have to consider seal or floor value also. All right. See, let us continue from that same point. Okay. Then before looking at other operations, suppose you are finding the time complexity of a algorithm, and when you are finding out, you got the answer as 2n square plus 3n plus 4. Then the highest degree is this one. So we give the answer asymptotically, that is O of n square. So it means this polynomial was not important. Approximate answer was important, that is O of n square. Now for some algorithm, you got the time complexity as 2 log n plus base 2 plus 3. Now for this we say log n, right? O of log n. We write like this. But in some cases, this function is also important. This function is important, right? Some cases we want this one, or most of the time we want just O of or big O of. We want only this answer. We don't want this function. Sometimes the function is important. All right. So when it is important, now let us take an example. Let us understand this one. You have one algorithm, means a procedure, and you are analyzing it. Listen, it's your algorithm, you are analyzing it. Now, when you are analyzing, what actually you want to know? What are the results that you are expecting from the analysis? You want in-depth analysis. Then I want exact equation. This is important. Now I want rough idea. This is okay. Your algorithm, you are analyzing. Then what you want to know, you know it better. You want this one or this one, that's up to you. Over. Now, I am giving you algorithm. I want exact answer. You should give exact answer. I want asymptotic answer. You should give asymptotic answer. Understood? So in GATE question, he can ask you this also, he can ask you this also. So you should know both. You should know both how to get this X1. So that's the point. That was the point where we got the answer as log n. In that plus 1 or 2, that is also important sometimes. Or whether it is floor or seal, that is also important. So when it comes to log, then floor or seal is important. Then after that, plus 1 or plus 2, whatever it is, that is also. So that type of question also they have asked, where they are asking exact number of times the loop is executing or exact number of time the condition is checked, like that. So there you have to give this specific answer. Log base 2 floor plus 1 may be your answer. So this is, you are giving the exact function. This means you are giving an exact function. All right. Now, let us go ahead further. We have discussed about binary search. Now, along with this, I'll discuss something. Suppose I am writing a piece of code, x assign 2 into A plus 3 into B. I am going to talk about time complexity of loops. Time complexity of loops. I am going to talk about time complexity of loops. See. Now, if I am writing this statement, what is the time taken by this simple statement? Time taken by this one. Asymptotically. Come on, just one single statement. How much time it takes? O of 1, O of 1, O of 1. All right? It means any single expression, we consider it as O of 1. All right? Now, my next question is, how many operations are performed in this expression? Total how many operations? 1, 2, 3. So if you are concerned about the operations, then you should count the operations. Otherwise, you should consider it as just one single statement. Now, next. For I assign 0, I is less than n, I plus plus. Print I. Just a pseudocode I am writing, not printf, percentile d, everything. Now, this statement takes n time. This statement takes n time, right? Why? Because this will repeat for n times. So, if I say this statement takes just 1 unit of time, but it is inside the loop, so it will repeat for n times. Now, watch this. Watch this. I have not written complete program or a function here, just I have written a piece of code. In this, you tell me, this statement will execute how many times? 1 time. This will execute how many times? This executes for n times. Then inside this will repeat for how many times? N times. Then how many times condition is checked? N plus 1 time. This is a C language syntax, right? Though pseudocode, but it is similar to C language syntax. Now you tell me, total time function is how much? Come on. Three n plus 2. 3n plus 2. Understood this one? This is 1 time. this is n time, right? This is n plus 1 time. You know very well, this is going to repeat for n times. So exact function is what? 3n plus 2. Over. Now, next. Usually when we see for loop in textbooks, you find it as n plus 1. Have you ever seen this? We'll not write everything. We just write what? N plus 1. Why n plus 1? Because the condition will be checked one time extra. One time extra. That's what we say. This is one time extra. But what about initialization and updation? We don't consider it. Then if you are writing it like this, then what is your function? F of n is equals to how much? 2n plus 1. Answer is different. Answer is different. But final answer is what? Final answer is what? So when you are concerned about the final answer, whether you write it as 2n plus 1 or 3n plus 2, both are same only. Same means that's useless for us because final answer is important for us. Both give the same final answer. Alright? Understood this one? Usually even in any textbook, today's textbook also, you find for loop means n plus 1. But actually this was for this one, for I assign 1 to n do. This was the syntax used in old programming languages. So here, initialization, updation, all are inside only. Just we say that this loop will repeat for n plus 1 times. We say like this. That's how we used to write, just n plus 1. But now in C language, we have 3 portions here. We know very well that which portion execute how many times. This is 1 time, this is n time, this is n plus 1 time. So then the time should be different. Time function should be different. But still we follow the same practice that for loop, we write n plus 1. That's it. Because finally you will get the same answer. We go of n only. Because we are not concerned about this. We are concerned about this. And I said just now that if you are concerned about this, then you should give a correct answer. Alright. Sorry. When you are concerned about the function, then you should give the correct answer. Now my question is, how many times updation is done in this loop? That's it. That's it. How many times condition is done? Checked. N plus 1 time. That's it. Alright. So, now actually, I am covering this topic. This is a different topic. Finding the time complexity. You will practice various type of code and look at them, various type of things you'll see. But I am writing this because we have covered, binary search. And we found out the time complexity is what? Log n. So for that, I'm just explaining few things here related to the time complexity. Otherwise, I should cover it as a separate topic called time complexity. All right. So is it okay? Now in this, I'll remove this. Now, what you want to, how you want to copy this, it's up to you. You can take this time complexity, just a small topic, little bit discussion, just to know about log n. So that further you have a lot of things which are coming up where you will be saying log n many times. So you should be aware of it. That's why I'm covering this portion. For loop is there. For loop means log n. Sorry, for loop means order of n. Now, when you wanted this answer finally, you don't need this entire function. Just this was enough for you. How many times printing is done? That was enough for you to give the answer, right? Chalo. Let us write a few more pieces of code. For recursion, I have explained you what is the time taken in recursion, right? But now, for loops, I'm discussing this one. Now watch this. Watch this when I'm writing. For I assign 0, I is less than n, I plus assign 2. It's not I plus plus, I plus assign 2. I plus 2, then plus 2, plus 2, plus 2. I is incremented by 2 every time. So print n or print I. Now how many times this is printed? N by 2. So still the time is how much? Out of n. By 2, we ignore that, just we take the highest degree of a polynomial, that is n. Alright? I have not written the complete function now. Just based on that statement inside the loop, I have given the answer. Now if you write a complete statement also, function also, and find it, then it's order of n, because we are concerned about this one. Now I'll write one more. For I assign 0, I is less than n. We don't know what is n. Don't always think n as a 10 or 5. N means we usually, when we do programming, we give n as maximum 10, right? So n can be 1 million, 10 million, or 100 million also, billion also, trillion also. N can be anything. For I assign 0, I is less than n, I plus assign 100. And here, print I. How many times this will execute? N by 100. And still the time is in big O of n only. So take these. N plus assign 100 also. If you think n is 10, then sir, it's very big. No. N is billion, trillion, whatever you want, you can take a bigger number. So even if it is n by 100 also, we say big O of n. So n by anything, we just say n. Unless it is n by n. N by n is 1. No? Until then, we'll say n only. So if you have loop, then how you should know the time complexity? That's what I'm discussing a little bit. N by n? Code we cannot write. Code we cannot write. But in mathematics, you can write n by n. So for every mathematical equation, you don't have the code here. So here itself, I'll continue. For I assign n, I is greater than 0, I minus minus, or greater than or equal to 0, greater than or equal, okay, greater than 0 or equal to 0, chalo. Greater than 0, I minus minus. Now, if you are printing or doing something here, whatever the expression may be, it need not be print always, whatever the statement you have, how many times this will execute? N times. So it's again O of n. So this is a decrementing loop. This is incrementing loop. This is decrementing loop. So incrementing or decrementing, it's same thing only, it's big O of n or order of n. All right. So take this last thing, then we will discuss something different. I is greater than 0, I minus minus. See here, in loops, I is a counter, and when it reaches n, it's stopping. And this is being modified by incrementing. And this is being modified by decrementing. So in loops, you can modify a variable by either increasing as well as decreasing. But in recursions, you have seen recursion in the beginning. You can modify a variable only by decrementing only. Right? You can do it incrementing also, but usually we do it using decrementing only, by decreasing only. Usually we do it like that. Okay. Now, coming to the next important thing for which we were discussing this. Sure. For I assign 1, I is less than or equal to n, then I assign 2 into I. Print I. How many times this printing will be done? This is not n. Sure, not n. So even you can't say n by 2 also. It's not n by 2 also. If it is incrementing by 2 steps, then you can say by 2. 100 steps also, and by 2 you can say. This is getting multiplied. So you cannot say n by 2 this time. This is different. This look different, right? Just blindly you cannot give that answer. So then what it is? So anyway, some of you have given the answer, but I should explain this, what it is. Okay? So I'm explaining. Watch this carefully. See, let us analyze this by taking steps. Do we know how many times this is going to execute? We don't know. So let us say k times. It's going to execute for k times. That's what the k we want to know. How many times? It's going to execute for k times, not n times at all, definitely. So let us say k times, and that k we want to know. So initially, I is 1. Right? Next time, I is 2. Next time, I is into 2 again. So this is 2 square. Let us write like this. Getting multiplied by 2 powers of 2. So then next time it is 2 power 3. 1 time. Okay, this was the start. Let us say like this. 1 time, 2 time, 3 time. 3 times. This is giving times. Who is giving times now? Power is giving times. Power is giving time. So on. Finally, 2 power k. At 2 power k, it will stop. So up to k minus 1, it will execute. So include that first time, it will be total k times. And you know very well when it will stop. When it will stop, I has become greater than n. It will stop when I has become greater than n. All right. So 2 power something greater than n. We know that we don't know how many times it's executing. It's not n. So we said k. So we want to find out that k. So we can see that it's repeating just 1 time, 2 times, 3 times. So it is dependent on k times. So 2 power k. So 2 power k is greater than n. So if we take that inequality and write it here, so 2 power k, and make it as equal to know what is k here. So what is k here? If you take k on this side, then 2, that is in base, will go on that side. So it becomes how much? Log n base 2. So we got the answer for k now. Yes. How many times it's executing? Log n times it's executing. Understood this one? So I is getting modified by getting multiplied by 2. This was incremented, decremented. Now we are looking at multiplied by 2. Multiplied by 2. This is the inequality we got now. So you can keep it as it is also. K this side. So k becomes when it becomes greater than log n base 2. Same thing. So I just wrote it as equal to and changed the side. You can easily understand in equal to. So I have done it. So keeping it unequal also, you can do it. k this side, so log base 2. So k becomes greater than log n base 2, then it will stop. So it will repeat for log n times. So this will repeat for O of log n base 2 times. So this is answer is O of, not exact. If you want exact, you should count it. This was like a table. Then finally, this is the deduction. So I have separated them. Finished. Now, next. Let me finish writing. Just watch. Just watch. For I assign n, I is greater than or equal to 1. I assign I divided by 2, print I. I started from 1 into 2 into 2 into 2 into 2. That is successive multiplication with the 2 and reached n. So answer was log n. Now I started from n and going towards 1 and by 2, by 2, by 2, successive division. So is it not just like this? This was going in this direction and this is going in this direction. So what is the answer finally? Log n. Log n. O of log n. Log n base 2. Understood this one? Successive increment. Answer is n. Successive repeated decrement. Repeated multiplication. Means the variable which is deciding the control of the loop, that is changing, right? How it is changing? Repeated multiplication log n. Repeated division also it's log n. Successive division or repeated division it's log n. All right. So if you want to do it in the same way, you can get the similar thing. You can do it now, right? By yourself as a homework, you can do it. I have shown this I is incrementing. So here it will be getting divided. So n first time, n by 2, n by 2 square, n by 2 cube. How many times? N by some number of times. We don't know how many times. But it will become 1 or 0, it will stop. So k times. That k we don't know. But we know that this becomes what? Less than 1. It will stop. Less than 1. So what is this? 2 power k. It's say, okay, other side if I write, if I change the side, chalo, वैसा नहीं, ऐसे लिख देंगे, n is less than 2 power k. So 2 power k is greater than n. Same thing we got. So k is how much? Log n. So just roughly I gave you the idea, you do it as homework. Okay? Oh. So Now I'll be writing the piece of code. You have to tell me the time. Okay. Here itself. Okay. Here itself I'll write. Array. For I assign 1, I is less than n. I assign I into 3. Print I. This was log base 2, log base 2. This is going to be log base 3n. Log base 3n. Of log base 3n. Getting divided by 3, so it is log base 3. Base 3. Getting multiplied by 3, so it's log base 3. Log base 3. Over. Now, next. Till here is okay. Now, I assign 1 while I is less than n. Print I. I assign I multiplied by 2. How much? Log n. Log n base 2 only. Same thing. Instead of loop, I have used while loop. Afterwards, you copy this. Afterwards, you copy this. Wait a minute. Then, start assign 1 and assign n. While start is less than end. Less than end. Mid assign start plus end by 2. Pseudocode. If some condition, then start assign mid plus 1. Else and assign mid minus 1. How many times? Start to end is n. N. Same n. Right? Here also n, right? N. Start to end is n. And that is divided by 2. Divided by 2. Shape is different, but the similar thing is happening. Do you agree with this? So how much time? Log n base 2. Log n base 2. So entire thing, start to end, right? Start to end is getting divided by 2, divided by 2. Whatever the pieces are there, and that is again divided by 2 every time. So this is going to be log n base 2 only. This is going to be O of log n base 2. And this code resembles our binary search. Binary search. This resembles our binary search. Because in data structure, you should know you should tell the time complexity also. That's why I'm covering this one, right? Little bit. But analyzing or finding the time complexities, again, in algorithms also you'll study it thoroughly. So little bit I'm covering it here. That is different and this is different. Can you hear me, online students? Okay. Thank you. अब सुनो एक important point. There's a plant. I am growing a plant, right, in a pot. Now I know that this plant will double its height every day. Double its height every day. Now it was suppose 1 feet, then it will become 2 feet. Now 2 will become 4 feet. Every day it will double its height. And my desired height is n. After that, I should stop giving water. It will stay there on. It will stay as it is. Okay. Desired height is n. Then how many days I will reach that desired height? Log n. Ho gaya. Ho gaya. Did I write the code here to get the answer from you? No. So you have analyzed the situation. You have analyzed the working. In words only I told you, you analyzed the working and based on that you have answered it. So you gave me the time complexity. Then the other method you are looking right now is from the code you are giving me the time complexity. Right? So now the point I have to tell you here is that there are two methods of giving the time complexity. One is based on the working, other is based from the code. So which is the right method? From the working. If you understand the working, you are giving the time. Other method is from the code. So which is the correct method? प्लांट का कोड लिखो. प्लांट का जो एग्जाम्पल था उसका कोड लिखो. लेट x इक्वल टू इंटीजर x इक्वल टू प्लांट, ऐसा कुछ तो भी लिखो. कोड नहीं बनेगा, हर चीज का कोड नहीं बनेगा. So for every procedure you can tell the time. For every procedure, you can give the time complexity, right? For every procedure, you may not be able to write on the code. But we are talking about the computer science part or programming part, then we have both the things here, procedure also, and for that same thing, we have the code also. So actual method for giving the time is if you study the procedure, based on the study of your procedure, you should give the time complexity. Based on the study, this was a very small problem, so you quickly gave the answer. Otherwise, you should study in detail, using pen and paper, then give the time complexity. That is the actual method of giving the time complexity. आ गया समझ में आ गया? Now from this code, what you are doing? Is there any procedure involved here? No, no. Are you understanding what is the procedure here and giving the answer? No, you are not understanding what is the procedure. I gave if something, you are not concerned about that, what is happening. You give the time. All right. So you are actually learning how to find out the time complexity from the code given to you. If I teach this to a non-programmer also, can he give the time for any program? Yes. Without knowing what is happening inside also, you can give the time. So this is a blind method actually. The actual method is you should understand the procedure thoroughly and give the time. If you understand thoroughly, then you can give any answer from that, not just the time. Are you getting me? Are you getting me? This is actually not a big thing. This is a very simple thing. Or this is taught to the naive programmer or the naive analyst, beginner analyst. n दिखा तो n लिख, फॉर लूप दिखते n लिख दो, बाई 2 दिखते log n लिख दो, ये सिखा रहे हैं, right? This is what we are teaching. So but mostly we get confused with this one only. कोड को कैसे करेंगे? कोड को नहीं करना है आपको, प्रोसीजर को करना है. टाइम कॉम्प्लेक्सिटी, यू हैव टू टेल द टाइम कॉम्प्लेक्सिटी फॉर द प्रोसीजर, नॉट फॉर द कोड. Understood this one? So this is not a big thing, but from the procedure, if you are giving the time, that's the big thing. All right. Whether you write on the code for it and then you do it, that's okay. But from the procedure, you should give the time complexity. So here you are learning how to find out the time just by looking at the code. So in GATE question, sometime they will just explain the procedure and ask you the time. They will not give you the code every time. If they are giving you the code, then what are the elements you should identify and give the answer? That's what I am showing you here. Sometime they give the procedure, sometime they will give you the code also. All right, understood this one? Chalo. Next, you know this. Just few more pieces of code I will write on, then we'll stop and we'll continue our topic. For I assign 0, I is less than n, I plus plus. You know the answer for this one directly. So j assign 0, j is less than n only, j plus plus. Print I comma j. I want to print these two things. So these are nested for loop. Then how many times this will execute? Loop inside loop. So loop inside loop means what? N inside n. Not n plus n. Not n plus n. Right? This is n inside n. N inside n means n into n. N into n is nothing but n square. O of n square. Loop inside loop is n square. N times. N times. See this for loop, inner for loop, how many times? N times. Or let us say n. That is repeating for how many times? Outer for loop is repeating for n times. N is repeated for n times. So n square. N is repeated for n times. So you can write it in words also. This is n. This takes O of n and repeated for n times. So this is n into n, n square. I'll change it. नहीं उधर लिख देंगे इसको. For I assign 1, I is less than or equal to n, I plus plus. For j assign I, j is less than n, j plus plus. Print ij. Then how many times this will execute? O of n square. But that is not same as this one. This is also starting from 0. This is also starting from 0. But this is starting from, okay, 0 to less than n. So this is 1 to n. Okay, it's same thing only. But this is not starting from 1 onwards. This is starting from I onwards. Let us take, for example, n equal to 5. Example, n equal to 5. Okay, so we need I and j. We want how many times this is printed. So this is inside j. All right. First time I is equals to 1. So j will take the values 1, 2, 3, 4, 5. So this is how many times? 5 times. The next time I is how much? 2. So this will be from 2, 3, 4, 5. Oh, sorry, this is less than or equal to only. 5. So this is how many times? 4 times. Next time I is how much? 3. So this will execute for 3, 4, 5. just 3 times. So if you observe, this is executing for, this is executing for 5 plus 4 plus 3 plus 2 plus 1. You agree with this? So this is nothing but 1 plus 2 plus 3 plus goes on to whatever the value of n is. So this is nothing but n into n plus 1 by 2. So this is O of n square. O square n square. So after tracing it thoroughly, we got the answer as n square. Now from now onwards, blindly we can say n square. Unless we want exact count, we can blindly say we go off, O off. If not O off, if you want how many times, 10 times, 15 times, 30 times, if n value is given, then you should count it. Obviously, n square is bigger than n into n plus 1 by 2. It's bigger. So if you want exact answer, then it's n into n plus 1 by 2 after tracing that one. So you should know how to trace it. So with practice, you'll know this one, how to trace. You may be doing more in algorithms, so I'm just touching the topic, that's it. Because that starts with time complexities only. Over. So we'll move further. Remember, we are in the topic operations on array, right? But we started time complexity to cover this one. I could have started time complexity at the beginning of, so I should cover it completely then. I should cover it as the entire topic. But now we took a chance and we are just going a little bit in detail of it. Now you have to tell me this one. For I assign 0, I is less than n, I plus plus, and inside this you have for j assign 0, j assign 1, j is less than n, j assign 2 into j, and something is done inside here. So how much time this piece of code takes? Outer loop you can clearly see it's n. Inner loop you can clearly see it's log n. So this is O of n log n. O of n log n. Now for I assign 1, I is less than n, I assign I into 2. For j assign 1, j is less than n, j assign j into 2. Something is happening here. So how much time this piece of code take? Log n into log n. So log base 2n, log n into log n is log n square. So where I should write square? Here? No, outside is for big O. Order of. So no. Log n power 2 is nothing but 2 log n. So if you have to say log n whole square, then you should write log square n. Square is upon log. Square is upon log. So that's how we differentiated log square n. So to avoid confusion, I'm just removing base 2. Right? So log n into log n if you have to say. So power 2 should be given to log, not to n. Finished. Can't move. ठीक है. Over. Now, what's the next operation that we have to discuss? I already have discussed about binary search. One method of analyzing, I have drawn a tree and I have shown you. Second method is from the code also, you can see that it's log n. So I have given you the reason why we are saying log n. So I have traced the code also. Now, when you see a piece of code also, you should be able to answer it because you can answer from recursion. So you should be able to answer from loops also now. All right. So what is the next operation we have? Yeah. Sorting, there are various sorting methods are there like bubble sort, selection sort, insertion sort, merge sort, heap sort, quick sort. So many sorts are there. So all those sorts, we will learn them together because there are a lot of questions related to sorts. There are some properties of sorting like whether they are stable or not, or whether they are in place or not in place. These type of questions are there about sorting. And what is the best case, worst case, average case. So in comparison with all sorts also, there are some questions asked. So that will cover later, sorting. So if I have to touch, just I'll be touching bubble sort and selection sort, nothing else. All right. So if I have to show. So are you aware of bubble sort and selection sort? No? ओके चलो कवर कर ही देते हैं. ठीक है, फिर बाद में रिपीट करेंगे उसको. अब यहां पे थोड़ा कंफ्यूजन ये है कि कौन सी टॉपिक किधर कवर होगी. मर्ज सॉर्ट इज डिटेल इन algorithms. Quick sort is in detail in algorithms. And that again needs insertion sort, bubble sort, selection sort. Again, they need that. ठीक है. So anyway, let us cover sortings. Okay, let us cover sorting. So I'll cover few sorting methods. So what are those? Bubble sort, selection sort, and insertion sort. I'll cover these three sorts. Let us start. Bubble sort, selection sort, insertion sort. So I'll take few elements here. I'll take a small size array. Small size array. 8, 6, 3, 4, 2. 0, 1, 2, 3, 4. I have an array of 5 elements and I want to sort them. For sorting, there are various techniques and there are some advantages and disadvantages of over one another, right? And it's not like that you have some fastest sort, you use always that one. They all depends on the application in where you want to apply. So depending on that, every sorting is useful, but its behavior is different. So let us look at the first sorting method, that is bubble sort. So for understanding bubble sort, we will not draw an array horizontally, we will draw it vertically and we will discuss. So 8, 6, 3, 4, 2. Now watch this. First two elements are compared. Pair of elements are compared. If the first one is greater than second one, then we will interchange them. We continue. We will compare the next pair of elements. Every time we compare the next pair of elements. 8 is greater than 3, so we'll interchange them. So 3 comes, 8 goes 4, 2. Then we again compare the next pair of elements, that is 6, 3, 4, 8, 2. Next we compare the next pair of elements. So this is 6, 3. Again 8 is greater, so 8 is greater, so 2 will come up and 8 will go down. We'll stop. So 1, 2, 3, 4. 4 comparisons I have done. Right? I have gone through the entire array and I have made 4 comparisons. Because there are 5 elements, I have made 4 comparisons. And in 4 comparison, all the elements are not sorted. Only one of the element is sorted, which is that last element. So what has happened is the last element was settled at the bottom of an array, or you can say end of an array. If you see it horizontally, it has gone at the end of an array. If you see it vertically, it has settled at the bottom of an array. Just like when you are throwing a stone in water, stone will go and settle at the bottom. And if you observe, the smaller elements are moving up, just like the bubbles are moving up. When you throw a stone, bubbles will come up, stone will go down. From that sense, they have given the name as bubble sort. The effect is just like you are throwing a stone in water, so stone goes in and the bubbles will come up. So अब पता नहीं किसके ध्यान में ये आया, उन्होंने ये नाम बबल सॉर्ट दे दिया उसको. ठीक है, बबल मतलब ये है, ये इफेक्ट है उसका. So bubble sort means the heavier element will settle at the bottom, lighter elements will come upwards like bubble. हो गया? We have not got all the elements sorted, just we have done one. So this entire process of comparing pair of elements, all the pair of elements and moving the largest element at the bottom, we call this as pass. And this was our first pass. So for sorting all the elements, we should continue and perform more passes. So we'll take 6, 3, 4, 2, 8 as it is. We perform the second pass now. So when we perform the second pass, we'll compare first 2 elements, then 3 is smaller, so it will come up. Sorry, 6 is greater, so it will go down, and 3 will come up. So this is 8 as it. Then we compare these two. So 6 is still bigger than this one, so 4 comes up and 6 goes down, and this 2 is here, so here and this is here. And we compare these two, so this is 3, 4, 6 is bigger than 2, so 2 goes up and 6 comes down and 8 here. Will not compare further because already we have sorted 8, so we need not compare. Even if you are comparing, no change at all. No change at all. So here I have performed how many comparisons? 3 comparisons. So this was second pass. This was second pass. Let me finish entirely. Then you can note down whatever you want to take. Now, just 2 elements are sorted. So you can observe that in one pass, 1 element is sorted. In second pass, two elements are sorted. Total two elements are sorted. So if you observe here, if you want me to highlight, total these two elements are sorted so far. Now let us perform one more pass to sort rest of the elements. So next element, so this is 6, 8. Now we'll compare these two. Now 3 is not bigger, so there is no change. So it doesn't mean that whenever you are comparing, always swapping of element is done. So it's not necessary. So this is as it is. Now 4 with 2, so 4 is bigger, so this will change. So 2 will come up and 4 will go down, and this is so enough. Now we will stop. 4 comparison, 3 comparison, and this is 2 comparison. 2 comparison. And we got how many elements sorted? Comparing 4 with 6 makes no sense because already you have sorted. So total 3 elements are sorted, and this was our third pass. So in each pass, one element is sorted. Still, we have to continue sorting because we have not sorted all the elements. So let us take this 3, 2, 4, 6, 8. This is the result of the previous pass. We'll compare these two. Yes, 3 is bigger. So this is 3 is bigger. So 2 will come up and 3 goes down, and 4, 6, 8. Stop. 3 with 4 is of no use because 4 was already sorted. So now you can see that total we have 4 elements sorted, and this was fourth pass. And already, when you have sorted 4 elements, means fifth is automatically sorted. You don't have to do anything. Okay? Acha, one more point. If the element is greater than swap. If it is smaller, don't swap. If it is equal, don't swap. Equal also, don't swap. So I have not taken equal elements here because just I have taken 5 elements. If the elements are equal also, don't swap. So swap only if the first element is bigger than the second and next element. All right. If this is greater than this one, then only swap. In a pair of elements, first is greater than the second one, then only swap. Otherwise, don't swap. You are sorting. You're not searching. You can have duplicate element also. If you have duplicate elements, then don't swap. Okay, understood this one? For n elements, how many passes were performed? N minus 1 passes for n elements. N minus 1 passes for n elements. All right. Then total number of comparisons. Total number of comparisons. Tell me. In this example, you have 4 plus 3 plus 2 plus 1 as per the example. Then for n elements, n minus 1 plus, n minus 2 plus, n minus 3 plus goes on to 3 plus 2 plus 1. So this is nothing but n into n minus 1 by 2. So this is how much? Order of n square. So the time taken by bubble sort is order of n square. Take this now, bubble sort. one comparison. Over. So the time taken by bubble sort is n square. Now let us write a piece of code for bubble sort. Watch this. Array is there. Shall tell me the program for this one. Piece of code. Not a complete function, everything. For we have to do swapping, right? Swapping. Shall we write down that piece of code first? For just one pass, for one pass. That will be easy. For one pass, we will write on. For, and the passes we have to repeat. So I'll take for j assign 0. Is it okay? And j is less than n. J plus plus. Using j I am writing. Now what I have to do? If a of I is, sorry. A of j is greater than. You should not say, okay, less than also you can say, not less than. Greater than, not less than. A of j plus 1. So j plus 1 means when you have reached here, you don't have next element. So this is it should go up to -1, n minus 1. Anyway. Now if so, then do what? Swapping. So for swapping, what you should do? Temp assign a of I and a of I assign. Just watch. Later you can copy. A of j. This is very important. Just watch this one. A of j assign temp. We will stop here. Okay? हाँ. अच्छा. अरे ये गलत हो गया. ओके. J A of J and A of, मैं आई जे का कोड लिख दिया. ठीक है. हाँ. A of J plus 1, A of J assign A of J plus 1. Sorry. Yeah. A of J plus 1 assign what? A of J over. हाँ. अरे M. हो गया. This is just first pass. One pass. One pass. I should go on repeating the passes. So this is for repetition. I assign 0. I is, this is just for repetition. I is less than n minus 1, right? N minus 1 passes. I plus plus. Over. Now one more thing. Will it always go up to n minus 1 or nahi? J, this is comparing, na? J start from 0 up to n minus 1. So always if we are comparing up to n minus 1 or we are reducing one element at a time. Reducing one. In first pass, no reduction. Next pass, one element less. Next pass, two elements less. So what I should do? Just n minus 1 is not enough. N minus, okay, I minus 1. N minus I minus 1. So I'll write this portion once again. N minus 1 it was. So I also I should subtract. So let us write I first, then n minus I minus 1. All right. N passes. N minus 1 passes. नहीं. 0, 1, 2, 3. 4 passes. N is 5 here, 5 elements. So 5 minus 1 means what? 4. 0 to less than 4 is? So this is N is 5. So 5 minus 1. Less than 5 minus 1. Up to 3 only. Up to 3 only. 3 then 4 if you see the indices. Now to avoid confusion, so usually what I do is, I will not take array from 0 onwards. I'll take it from 1 onwards. So you understand the concept and the code thoroughly, then you change it to zeros. Right? You change it to 0. It's easy to convert later on. But keeping in mind from 0 onwards, sometimes create confusion. You can't exactly understand. When you have to understand the thing. Is it perfect? Everything clear or not? This is the code for bubble sort. And what is the time taken? You already know n square. On what basis you know? By analyzing its working you have given the time. Now from the code you check and tell me. Outer loop n, inner loop also n. Roughly we take n. So it's big O of n square. Big O of n square. But exactly how many comparisons it's making, if you want to count, it is how much? N into n minus 1 byte. over. Now, few interesting thing. Look at this. Comparisons we have already done. Total comparisons are n into n minus 1 by 2 is n square. We always. Yes or no? Next. Second. Total swaps. How many? Swapping the element. How many swaps? No, it's not always the same. It is swapping if the first element is greater than the second element. Only it is swapping them, right? Now, total how many it will be done depends on the array. So, can you find out minimum swaps and maximum swaps? So, first you tell maximum swaps. Maximum swaps. Every comparison swapping is done. So for every comparison swapping is done means it is equal to the number of comparisons. Do you agree with this? Sure. Swaps. Total swaps. So this is maximum, we are saying n into n minus 1 by 2 number of swaps equal to the number of comparisons. So let us say it's order of n square. And can you tell me when this will happen? Can you tell me? You have any idea when this will happen? Every comparison swapping is done. 1, 2, 3, 4. Tell the numbers 10, 8, 6, 4, 2. Descending order. They are in descending order. Alright. अच्छा. दूसरा वाला मिनिमम स्वैप. तो जब ये डिसेंडिंग था तो इफ वी ट्राई असेंडिंग ऑलरेडी सॉर्टेड 1 2 3 4 2 4 6 8 10. Swap is never done at all. All elements are already sorted. Just comparison and swapping is never done. Means actually you have given already sorted array and asked bubble sort to sort it. The bubble sort algorithm will simply run and try to arrange them. It will not see they are already sorted or not. We have written this code. Is it checking? This piece of code, is it checking? No, it's not checking. No sorting algorithm will check first of all. अरे ये तो already sorted है ना, कोई नहीं बोलेगा आपको. No sorting algorithm will do that. You should check it and send it. Because when you are writing a function for bubble sort, its job is to sort. Why to check it? Alright, so it will simply sort. And which is already sorted, so it will run the same thing, but it will make all these comparisons. Yes or no? Comparisons are as it is, same. But the number of swaps are 0. No swaps. 0 swaps. 0. But for that we write what? Order of 1. 0 is also a constant value, so we write it as order of 1. So number of swaps are constant or no swaps if array is already sorted. If it is in reverse, then it is n square. If it is already sorted, so we have identified the number of swaps also in bubble sort. कौन? इफ के अंदर एंटर नहीं होगा, लेकिन इफ का कंडीशन चेक होगा बराबर. तो सारे मिला के 2 फॉर लूप चलेंगे, n स्क्वायर होगा टाइम. नंबर ऑफ एन स्क्वायर कंपैरिजंस होंगे. Always. Number of comparisons are always. They are not more or less. They are not more or less. Number of comparisons always order of n square. There is no more or less. But swaps are more or less. Wait a minute. Swaps are more or less. है? Swaps are maximum. हाँ. Sorting के लिए. If array of elements are there, you want to arrange them in the increasing order, then you can use sorting. Sort arrangement करने के लिए, increasing order search arrange करने के लिए. अगर आपका क्वेश्चन ये है कि जब ये टाइम इतना ज्यादा ले रहा है तो कहाँ यूज करते हैं, क्यों यूज करेंगे, तो हम स्टडी करेंगे इसके ऊपर और तो फिर समझ में आएगा. इसीलिए सारे सॉर्ट्स अगर आप स्टडी करेंगे तो यू कैन नो दैट वेयर विच सॉर्ट इज यूज्ड, वेयर विच सॉर्ट इज यूज्ड. ओके. नाउ लिसन. Now from his question, I am raising one more question. If I want to find out just the 3 largest element in an array, 3 largest element in an array, then what I should do? Array size is 1000. I want just 3 largest element. What I should do? 3 passes of bubble sort. Where do you get the largest element? At the last. So you know bubble sort technique. You are using it not for sorting all the elements, but for finding some largest element, k largest element. That's how all the sorts are useful. You don't always use every entire sort every time. So you can make a note that for finding k largest element in an array, we can use k passes of, come on, k passes of bubble sort. Make a point there. For finding k largest elements in an array, k largest elements in an array, we can use k passes of bubble sort. चलो अब आगे. Next question. Okay. So we were discussing something else. He asked one question. So same question I repeated and we got something to learn. हो गया. Now back to this. Back to this. Minimum swaps when it's already sorted. ठीक है. But bubble sort will compare. If it's already sorted, doesn't know that it's already sorted. Now, can you make this bubble sort little bit intelligent so that if it is already sorted, it should stop sorting. It should stop sorting. आया समझ में आ गया? How do you know that it's already sorted? Because no swaps. No swaps. If there is no swaps, you can say that it's already sorted. Means it's not entering inside if. No swaps. तो कुछ कर सकते क्या हम? क्या कर सकते हैं? यहां पे हम एक फ्लैग ले लेंगे जो कि 0 रहेगा. Before entering into a pass, this is the pass, right? This is repeating the passes. Before entering into the pass, we'll make flag as 0. And inside this, if any time you are entering into conditional statement, then also after swapping, we'll make the flag as 1. Then once we have finished the pass, once we have finished the pass, we'll check. क्या flag अभी भी 0 ही है? इसका मतलब swap नहीं हुआ. So this is on inside outer loop. So break, stop. See, this inner loop was for comparing and swapping the element. This was running one pass. This outer loop is repeating the passes. Before each pass, we will make a flag as 1, 0, and we check if there is any swapping, we make a flag as 1. Then after the end of this pass, we will check if the flag became 1 means it is swapping was done. If it is still 0 means what? There is no swapping done. Means it has not entered into this if at all. Right? So when we come out of this for loop, we check flag 0. Ek bhi swap nahi hua. Break. If there is the one swap also, this will not be, this will become 1. If there is a single swap also, this will be 1. If no swap in the entire pass means what? Understood this one? समझ में आ गया? So now you tell me, by introducing this flag for already sorted array, no swaps, but how many comparisons? How many comparisons? Come on, come on. n-1. Comparisons is done or not? After completing a pass, it will check 2 is not greater, 4 is not greater, don't swap, 6 is not greater, don't swap, 2 is not greater than 4, don't swap, 4 is not greater than 6, don't swap, 6 is not greater than 8, don't swap, 8 is not greater than 10, don't swap, no swap, no swap, no swap, but it has compared all of them. So how many comparison in this case now? n-1, so it's big O of n, big O of n. Now we have changed the number of comparisons also. Till now we were saying that always n square, but now for this array, maximum comparisons are also n square. For this array, maximum number of comparisons are, come on, O of n. Now you tell me minimum time, time taken by, time taken by bubble sort. Minimum how much? O of n. Maximum how much? Don't copy anything. Order of n square. This is when already sorted. Okay, just I am writing here. And not sorted. Already sorted, not sorted. Minimum time taken by, listen, just listen, go on listening. Minimum time taken by bubble sort is big O of n, maximum time is n square. Now one thing, we are doing what? Comparing and swapping, comparing and swapping. So comparison is also one process, swapping is also one process. But when we are saying time, we are considering what? Swappings or comparisons? Comparisons. We are checking comparisons, not swappings. Remember this. All right. So because sorting mainly does what? Comparisons only. If swapping required, it will do. Otherwise, it will not do. So major task is swapping. That's why we are measuring the time based on not swaps, based on comparison. Okay. Ab suno. Now last point. We have a modified bubble sort. And this bubble sort is called as adaptive bubble sort. You have to note down. Wait a minute. Adaptive bubble sort. What is adaptive? A sorting technique which takes less time in case if the list is already sorted. Such a sorting technique is called as adaptive sorting technique. आ गया समझ में आ गया? So what we have made just now, what we did? Adaptive bubble sort. Wait a minute, don't copy. Adaptive bubble sort. So what is adaptive? A sorting technique which takes less time. If array is already sorted, then we'll say it's adaptive sort. Adaptive sort. So this is adaptive bubble sort. And this is taking minimum time as n and maximum time as O of n square. So now you have to make a side heading as adaptive bubble sort and then write what does it mean by adaptive, right? What does it mean by adaptive? Then you write on this code. Wait a minute, what didn't you write on this code? Then you write the explanation why you have written this code. You are saying that if no swaps in a pass, then break, stop. Whenever you find there is no swaps in a pass, you will stop. Right, suppose, wait a minute. 8. 2, 3, 4, 6, 7. If this is the list, what happens? 8 इधर गया, उसके बाद उधर गया, उधर गया, उधर गया, लास्ट में चले आता है 8 फर्स्ट टाइम में ही. Now next pass, no swaps, just 2 passes stop. So almost it is order of, come on, order of n only, order of n only, right? If suppose 100 elements, just I have taken 5 here, 5, 6 here, 100 elements or 1000 elements, just one pass over, second pass comparison is done. So 2 into n, this means order of n only. So it's faster. Understood this one? So already sorted hai to just n hota kaisa bhi. If it is not sorted, 1 or 2 elements are also sorted, so almost it will take. So it means what? It takes the time in between n to n square now. N to n square. Time in between n to n square. So lastly, once again I am repeating what you have to write on. You have to write on adaptive bubble sort. Adaptive means what? If already list is sorted, if an algorithm is taking less time, then it's called as adaptive, and the bubble sort can be made as adaptive by introducing a flag. You have introduced a flag and the time taken is big of. You can take the notes now. I'm not dictating, you should write it from your side. You are preparing notes by yourself so that when you go through them, you can recall the topic. So you write it in English or Hinglish or Telugu, whatever you want, you write it. N. Minimum time of bubble sort is n. Minimum swaps are 0. हाँ बेस्ट टाइम वही होगा. बेस्ट इज ऑफर, मिनिमम या बेस्ट इज सेम. Best case, it's already sorted. Worst time, n square. Worst case, reverse sorted. Over. Now, a note, important, a note, just listen first. Bubble sort, was it adaptive by nature or we made it adaptive? So bubble sort is not adaptive by nature, but it can be made as adaptive. There's a note you have to write on. It's not adaptive by nature. By itself, it was not stopping. We made it stop. So bubble sort is not adaptive by nature, but it can be made as adaptive. It can be made as adaptive. हो गया? हाँ, नहीं प्रोसीजर, ये प्रोसीजर में नहीं था ऐसा. First we learned the procedure that was not there in the procedure. Then we wrote the code based on the procedure. Then we modified the procedure. So basic procedure is compare and swap, compare and swap. Compare and if required, swap. But in basic procedure, there is nothing like if already is there, so ये flag नहीं है उसमें. हो गया? Now we learn one more thing about this sort, bubble sort. This we made it as adaptive, and this is the time complexity over. Chal. Listen. I have the elements 8, 6, 3, 8, 4, 7. This is an array. Okay. I'll make it as an array. 1, 2, 3, 4, 5. ठीक है. So आज एक मिनट. Eight. ठीक है. Now actual, then sorted by bubble sort. A 2, 2, 4, 2, 6, 1, 2, 3, 4, 5. Tell me the numbers after sorting. हाँ अरे हाँ 3, 4, 6, 7. कौन सा 8? येलो वाला या पिंक वाला? पहले कोई भी नहीं है, दोनों का कलर अलग अलग है. देयर इज अ डिफरेंस. देखो, देख लो. Swapped. 8 is greater. This is yellow 8 now. Swapped. 8 is greater than 3. Then yellow 8 and pink 8. No swap. Then next 8 with 4. Then 8 with 7. तो यहां पे येलो रहेगा और यहां पे पिंक वाला रहेगा. ठीक है. 2 एग्स है. इसमें उबालने वाला कौन, बॉईल करने वाला कौन सा है, फ्राई करने वाला कौन सा है? दोनों भी एग्स ही है. ठीक है. कौन सा भी फ्राई करो, कौन सा भी बॉयल. तो दोनों भी 8s है, तो दोनों भी 8s नहीं है. वो 1 8 is different, another 8 is different. Two different 8s are there. Suppose they are definitely different 8s. Now why? I'll give you an example. Wait a minute. They are definitely different 8s. Then that's the reason I have given different colors. Now when you are sorting, listen. In the actual list, yellow 8 was first, pink 8 was next. In the sorted list also, yellow was first, pink was next. If any sorting technique is arranging the elements in the same order, once again I am repeating, if any sorting technique is arranging the duplicate elements in the same order, then we call that sorting technique as stable. Once again, if there are duplicate elements in the list and the sorting also, their actual order is preserved, then we say sorting technique used is Stable. So is bubble sort stable or not? Yes, it's stable. So I have explained you what does it mean by stable. And then also I have shown you that bubble sort is stable. If there are duplicate elements in a list, then sorted list should preserve the order of duplicate elements. Preserve the order of duplicate elements. So bubble sort was adaptive as well as stable. Adaptive and stable. Bubble sort was adaptive as well as stable. So actually there are only two sorts which are adaptive and stable. Bubble and insertion. That's all. Bubble and insertion. I'm covering it as a sorting topic instead of just showing you the code of bubble sort. We are going in deep. Like for binary search also we have gone in deep. Here also we are going in deep. हो गया? Now, अभी so this is a stable I have explained. This was about stable. Now the question is, what is the difference between this 8 and that 8? So let me show you one example and then you can understand something from there. Eight, Anil. 6, Balu. 3, Chandan. 8, David. 4, Mahesh. 7, Ravi. These are ranks. Ranks, two students can get same rank, right? These are the rankings. These are the names. Now you have to sort these ranks. Sort these ranks. The first rank, 3, Chandan. 4, Mahesh. 6, Balu. 7, Ravi. 8, Anil. Next 8, David. That's all. तो वो फर्स्ट वाला 8 अनिल का है, सेकंड वाला 8 डेविड का है. Both 8 are not same. So earlier I have shown you just integers. Now I am showing you records with just 2 values. Okay? Now if you observe, when there are 2 same ranks, the names are sorted. A, then M. The A and then D. A, then D. If ranks are same, their names are sorted. Do you observe this one or not? Achha, if you observe the first value what I have given you, actually it was already sorted based on names, not on ranks. Already sorted based on names. Then I am sorting based on ranks, so I am preserving the order. So what I am getting, if the ranks are same, they are sorted on their names. आ गया, समझ में आ गया? Is it useful or not? अच्छा, can you sort in the database ascending, descending? In SQL you can write ascending, descending, right? So do you write only one column in ascending or descending, one column, or you write multiple columns? Multiple columns. How it is possible that it's sorted upon 2 or 3 columns? So basically first column it is sorted, and if the first value is duplicated, it is sorted upon second column. आ गया समझ में आए? तो एसक्यूएल अगर सॉर्ट यूज करना हो तो कौन सा सॉर्ट यूज करे? स्टेबल वाला यूज करे. तो स्टेबल कौन है? हमारी लिस्ट में तो 2 ही है, ठीक है, बबल और इंसर्शन है. तो इन एसक्यूएल व्हेन यू से सॉर्ट, देन वन ऑफ द सॉर्टिंग, दीज 2 आर suitable. आई एम नॉट सेइंग दैट एसक्यूएल विल यूज दिस. व्हिच वन इज यूज्ड विल सी लेटर ऑन, बट it is suitable wherever you need. Stability की भी जरूरत क्या है भाई? So I have given you the answer here. Why do you need stability? I have given you the answer here. Is it okay? Got it? So that's it. Through bubble sort we learn what is adaptive. Through the bubble sort we learn what is stable. So 2 major things we have learned, and we have understood what is swapping and what is comparison. So almost everything about sorting algorithms we have learned through this one single example. All right. Now every sort you should see whether it is stable or not, whether it's adaptive or not, how many comparisons it's doing, how many swaps it is doing. For every sorting you have to do like this analysis. Okay? Finished. 2, 4, chal. 2, 4, 6, 8, 10. Increasing order. Yes or no? So no. 2, 4, 4, 6, 8, 8, 10. Non-decreasing order. ये इंक्रीजिंग है क्या? 2 से 4. 4 के बाद 4, there is no increasing. So we cannot say increasing order. So we say what? It's neither decreasing also. So we don't say it's increasing. We say what? Non-decreasing. अगर आप duplicate वो सब नहीं देख रहे हैं तो this is also increasing. This is also increasing only. In common terms. This is also increasing, but this is also increasing only. But increasing also called as non-decreasing when? If there are duplicates. So gate questions you will always find non-decreasing, non-increasing, non-decreasing, non-increasing. You will never find increasing or decreasing. Non-decreasing means? So actually it means increasing. Non-decreasing means actually it is increasing. Duplicate ठीक है भाई रहने दो. तो उसके लिए नाम बदल देने की जरूरत नहीं थी. बट एक्चुअल मीनिंग इफ यू सी, इट्स नॉट एट ऑल इंक्रीजिंग एवरी टाइम. Every time increasing, say increasing. Every time not increasing, so we can't say non increasing. So we say non-decreasing. All right. So at no place it is decreasing. At no place it is decreasing. That is the meaning. Non-decreasing. All right. So same way you have decreasing order and non-increasing order. So in GATE questions you will find non-decreasing, non-increasing, non-decreasing, non. You will never find increasing or decreasing. So they may be duplicates or they may not be duplicate. They use the same term. So now you know one important thing about sorted order. All right. So this is over. Next sort. I have covered bubble sort. I said I will cover 3 sorts that are basic sorts actually. So that we can cover upon arrays. So as I have given the list, in the list I have given sorting. So I'm covering 3 sorts. Let us start selection sort. A. एक मिनट. I have taken these elements. Let us look at selection sort. I'll explain first, then you have to note down. And for tracing, first I'll trace it, then I will write on the code, then you copy it. Watch. I will take this list here. 8, 9, 7, 3, 2, 5. Okay. So tracing cannot be shown here because there is no continuous swap every time. Comparisons are there. Okay. So I'll write on the steps. I'll write on steps. This is 0, 1, 2, 3, 4, 5. Watch here. Select I assign 0. This is I. Or this is nothing but select array. Select okay, element at index 0. Select element at index 0. So we'll take, so set I equal to 0. This is first step. Okay. Follow this carefully. Follow this. Because just I'll show 2 steps. That's enough. I will not sort all the elements. Okay, I'll not sort all the elements. Just 2 steps enough. Second, find smallest element from 0 to, अरे ये क्या हो गया, रीडू भी है ना, हाँ, फ्रॉम index 0 to n, 0 to n, roughly n, n minus 1 was up nahi, 0 to n, okay, till last index. Set j, or okay, set j, set j. So which is the smallest element? You have to find smallest element. So for finding minimum element, you have to do tracing. So I cannot show tracing here. Compare this with this one, this with this. You know very well. So I am not showing the tracing part here. So finally find out smallest element. So which is the smallest element? 2. So index j. That is j. Add j that. Then third. Swap a of I. A of j. Interchange these two elements. Interchange these two elements. So the new array is what? New array is what? 2, 9, 7, 3, 8, 5. And the indices are 0, 1, 2, 3, 4, 5. Okay. Now, how many elements are sorted? How many elements are sorted? Just one element is sorted. One element is sorted. Which one? Smallest or largest? Smallest. Smallest element. Okay. Understood till here? Understood till here? Let me complete one more step. Then, here we say select element at index 1. Set I is equals to 1. Now I is here. Second, find smallest element from 1 to n. Set j there. So which is the smallest element? 3. So set j there. Then third step is what? Swap a of I with a of j. So which elements are swapped? These two elements are swapped. Sorry. These two elements are swapped. Then what is the result? The result is what? 2 as it is. Here you will get 3, and this is 4 and 7. This is 9. This is 8 and this is 5. Indices are 0, 1, 2, 3, 4, 5. And if you see how many elements are sorted, 2 elements are sorted. Understood till here? Understood till here? Now listen. Select first place and find out who should come here. Find out who should come here. Select first place and find out who should come here. Smallest one, bring it there. What to do with this one? Send it there in his place. Then select next place and find out who should come here. Smallest among remaining all. Select a position, find a element. Selection sort. Select a position, find an element. Selection sort. Ho gaya? Ho gaya? Next. Next. For finding smallest of all these elements, roughly how many comparisons? N. Actually n minus 1, so n. Let us say n. Now the next pass, 1 less, so it is n minus 1. So now you tell me total passes. How many total passes? How many? You understood sorting, right? You understood sorting. Just 2 steps enough, right? So in 1 pass, 1 element sorted. 2 pass, 2 elements sorted. For n elements, n minus 1 passes. Total n minus 1 passes. Then total comparisons. Tell me total how many comparisons? First time, okay, let us say n minus 1, then n minus 2, n minus 3, n minus goes on, it is reducing. So this is same thing, you know, n into n minus 1 by 2. You know, same thing. So we give the time complexity based on the number of comparisons. So it's order of n square. Now, total swaps. I was doing swapping or first find smallest, first find Sorry, first select the location, find smallest, and then swap. So in one pass, second pass, one swap. So for n, so n passes, n minus 1 swaps. So number of swaps are order of n. So this is the only sorting technique which takes less number of swaps. This is the only sorting technique which takes less number of swaps. Understood this one? Got it? Suppose you will have to arrange trucks in the sorted order of their length. Then do what? Bubble sort. Trucks. Bubble sort. Too much movement. Right? Too much time consuming also. Then do what? First place पे कौन आना हो, smallest तुम इधर आ जाओ, इधर चले जाओ, last. Right, next place. Who should come next is smallest. You come here. And you go there. In this way, less number of swaps. So total for n trucks, you have to perform n swaps. Order of n swaps. So this is the only sorting which takes order of n swaps, less number of swaps. So every sort is having its own speciality. Now one more point. If you perform k passes, what do you get? Come on. K smallest element. Smallest element is here. Next smallest element is here. So you get k smallest element. If you perform k passes, you get k smallest element. So everything I have explained, because already this type of analysis we have already done, so directly I have written the answer. So I cannot illustrate, means there is no meaning in illustration because we are not swapping. Just you have to show comparison, so to find out the smallest element. So in words I have written it. First you select a position, then find the smallest element, then replace, swap. If you have duplicates, then you'll be taking the first smallest or maybe the last smallest, depends on the logic that you're writing. Is it stable? Stable means what? Not stable, right? Because नहीं, पता नहीं क्या हो गया है. नहीं, stable means what? Order of duplicate elements should not change. So, do you find it stable? कैसा? See, first time 8 came at index 4. 8 came at index 4. Next time 9 from here came at index 3. 8 नीचे गया, 9 उसके ऊपर आया. Suppose both were 8, 8. Then first 8 will go at 4. Suppose this is not 9, this is also 8. So this will go at 3. So order is change. Order is change. So it's just taking an element, throwing somewhere. So it's not properly arranging them. So it is not stable. So there is no guarantee that the duplicates will preserve their order. There is no guarantee. Understood this one? So it's not stable. It's not stable. Then can you make it adaptive? Is it adaptive by nature? Is it stopping at any point that, oh, it's already sorted? No, it's not adaptive. And even you can't make it as adaptive. In one pass, if there is no swapping done, means that position belongs to same element, it doesn't mean that the remaining elements are already sorted. Does it give the idea that? Suppose this is the list. 2, 8, 7, 6, 9. I here. J, same. Same position. Can you say that no swapping, already all are sorted? Can you say that? The rest of them are sorted? No. So we cannot say if no swapping means all are sorted. We cannot guarantee that. So you cannot even make it as, come on, adaptive. So it's not adaptive, it's not stable. Already I told you. Now, can you write down the code or homework? Shall I write down the code or homework? Homework. Chalo, ठीक है. See, I you will set. You have to find out the minimum and you should make J or K, whichever variable you want. You can point it there wherever its minimum is. So you need 3 variables actually. One is a loop for passes. Second loop will find out the minimum element and index will stop there only, wherever is minimum. We don't want the element, we want the index. Alright, so I, J, K also you have to use. I, J, K you have to use. Oh. Anyway, let us move to the next. Now we will cover one topic called as one operation on array is sorted. I have to cover insertion sort, but directly I will not start it. We will cover one operation that is sorted, then we'll cover one more operation, then we'll go on insertion sort. Okay? The elements are 3, 5, 8, 15, 17, 16, 19. Is this array sorted? Muni, you try that one. Yeah. You try the code. Maybe next class I'll show you. I'll discuss and I will show the code tomorrow. Selection sort code, because already all have agreed that we will try it as homework, so you do it. Okay, tomorrow just may leave a reminder, I'll show the code. Is it sorted? No. How do you check whether the array is sorted or not? Sorted or not? We'll check what? First with second one. This should be smaller, or it can also be equal. Right? This is smaller or equal. Start I from here. Start, okay, I from here. This is smaller than I plus 1. Yes. Smaller or equal? Yes. Okay. Sorry. Smaller or equal? Yes. Then move to next location. Is it smaller or equal? Yes, it's smaller. This is smaller. This is smaller. This is smaller than next one? No. This is greater. So here it's violating. So every next element either should be, this. Yeah, let us take it like this. Let us do it once again. Let us do it once again. So for in other way, see the same thing you can define in other method also. The next element must be greater than its current element. Next one is greater or equal. Greater or equal. Greater, yes. Next element is greater, yes. For this next element is greater, yes. For this next element is greater, yes. For this next element is greater, no. So stop. Stop. And say that it's not sorted. Or else if you have finished the array, then you can say it is already sorted. So tell me the code here. Okay, you said that you will write down the code for bubble sort. So tell the code for this one. For I starts from index 0, and as you have to check the next element, so you should not say just less than n, you should stop at less than n minus 1 and I plus plus. One more less. Okay, then what you should do every time, if a of I should be less than or equal, it's okay. When it is wrong, if it is, if a of I is greater than a of I plus 1, then it's wrong. Then it's wrong. Then we will just return 0. Or not 0. I will say false. I'm writing pseudocode here. False means 0. You know well. You can read, understand it. Now, you have checked this entire array. You have checked all the elements. Nothing was wrong. Then you will return what? True. And if you want to make it as a function, complete function, then you can make it like this. And here you can say Boolean. This is not C language, okay? Boolean is sorted, and you are passing an array A, and also you are passing number of elements. Then it will return true or false. Instead of bool, you write int, then it becomes C code. So, how much time it is taking to check whether the array is sorted or not? O of n. O of n. While loop? Here you are saying, we can use while also. Instead of for, can you use while? He's asking. Yes, you can write it using I. Same thing. Same thing. You have to take I as 0 while a of I is smaller than A of I plus 1. Acha, you are asking or saying that we can write it using पूछ रहे हो या बोल रहे हो? अच्छा, पूछ रहे हैं, ठीक है. तो what we should write on while A of I is less than, अच्छा, that become if. That become if. So what we should do? Just do what? Just one line. And if, bolo. This is smaller or equal also, no? Smaller or equal. Again, I have to use this one. Just 10 minutes. A of I is less than or equal to A of I plus 1. And also you should write on one more condition, that I should be, you should add one more condition. ऐसे ही चले नहीं जाएंगे ना, वो मिलता रहे तो आगे चले जाते जाएंगे क्या? कहीं ना, you have to stop it. Where I is less than n minus 1. Less than n minus 1. So you should have one more condition. So I will erase it and write it properly once again. You should check one more condition. I starts from 0 while I is less than n minus 1 and A of I is less than or equal to A of I plus 1. And inside this I plus plus. Now, his question was, can we write down this condition inside while? Not inside, again if, as a part of while. So if you are writing as a part of while, then you should add one more condition, that I should stop when it is becoming greater than or equal to n minus 1. It should stop. तो ये लूप रुकेगा कब? बोलो, ये लूप कब रुकेगा? या तो ये फेल होगा तो रुकेगा, या तो ये फेल हो जाएगा. तो अब कोई एक कंडीशन चेक करो आप. विच वन यू वांट टू चेक? दिस वन और दिस वन? This one. If A of I is less than or equal to A of I plus 1, then yes, return true. Else, return false. You are checking this condition. Based on that condition you are writing. क्या ये वाइल के अंदर नहीं है भाई, बाहर है. क्या वाइल के अंदर सिर्फ I प्लस प्लस है? सुनो, while this element is greater than or equal to that, go on. Smaller, 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 smaller than. Stop. Plus, 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 plus. Stop. Why did you stop? Because this was greater than that. Greater than that. So false. All right. That's how it's working. That's how it's working. So this is just the rough idea, not the executable code. Okay. Just the rough idea. Enough. This is perfect. Over, is sorted, completed. Completed. Now, next topic. Acha, just a minute, just a minute. What was the time taken by this one? Time is how much? O of n. Now, can you tell me what is the minimum time taken by this one? When first element itself has given the failed condition. So it takes minimum time as 1, maximum time as n. So usually we talk about maximum time. So we say O of n. Time is O of n, but the minimum time is 1, maximum time is n. मैक्सिमम टाइम n लेकर ही भी ये बोल सकता है कि नॉट सॉर्टेड, बिकॉज लास्ट एलिमेंट वॉज नॉट मैचिंग द सॉर्टेड ऑर्डर. Minimum time is 1, maximum time is n by this algorithm, That's what I told you. That's what I told you in the beginning. That was the discussion. Every sorting technique can first check this and sort, right? Sorting technique will not check it. You are calling sorted function. You are a programmer. You are calling it. So first you check it, then you call it. ये उसका काम नहीं है. उसका काम सिर्फ सॉर्ट करना है. अगर सॉर्ट पहले से है क्या, तो अगर है तो हमारा टाइम बच जाएगा. तो यानी सॉर्टिंग टेक्निक काम से बचना चाह रहा है. ये हो गया. तो हम उसको काम देना या दे देना वो हम डिसाइड करेंगे. काम दे दिया तो काम करना है सिर्फ. If we have given work, it should do it. So that's what, in this sense, we will not add this logic in every sorting technique. We can add this sort logic, right? It's already sorted. Don't sort, don't run the rest of the thing. So we don't add it there. Because this job is different, sorting job is different. Okay, that we already discussed this one. Finished? Now, next is, okay. Next topic is sorted insert. Topic is sorted insert. If you're taking the heading, take it and stop. Take it and stop. I have to explain something. Sorted insert. You know how to check whether it is sorted or not. Now the next thing is sorted insert. These are the operations in an array. I have given the list also. Now sorted insert. Watch this. I have an array of elements. One, two, three, 4, 5, 6, 7. Indices are 0, 1, 2, 3, 4, 5, 6, 7. And I have the elements 3, 6, 8, 12, 15, 19, 22. Is this array already sorted? Yes. But one extra space is there, right? So that I can insert more elements in this one. I can insert one more element in this array. Okay, I kept it intentionally empty. So the size of the array is 8, but the number of elements we have is only 7. And they are all sorted. They are all sorted. Now listen, sorted insert means inserting a new element in a sorted array in a sorted position. Means after inserting also, it should be in the sorted order. So suppose I want to insert a new element that is, let us say 10. Then I can insert here. And then I can perform sort. तो कितना टाइम हो गया? Just write down that value constant and sort. Sort, which sort is taking less time? So both are taking n square only, maximum time. So you should bubble sort or selection sort. So how much time it takes for inserting an element in a sorted array? O of n square, O of n square. Understood? So wait a minute. Just write the element and sort it entire. So is it not possible we don't blindly insert here? We insert in a proper position. Is it not possible? Yes, it's possible. So what could be that method? Let us try that method. I want to insert a new element that is x is 10. Insert this one. So where actually it should come? After 8. Listen once again. We have already a sorted array, right? and we want to insert a new element in an array at a sorted position. At a sorted position means after insertion also list must be sorted. So what we can do here? So for this, show the procedure. See, watch the procedure. We can start from here. What? From here shall we check where we should store? यहाँ से check करना, इधर से check करो. 10 is greater than 3, greater than 6, greater than 8 also. Smaller than 12. Okay, we should insert here. Found out. How much time it takes to find its position? N or not? Now what you should do for insertion? We are not overwriting. We have to insert in between. So what we should do? Shifting. From which side you will start shifting? From here only or from the last? आ गया समझ में आ गया? Understood? Now watch. We'll start shifting. So I am showing the procedure once again from the beginning. We are not finding the position. We are not finding the position. Just I am starting the procedure once again. Listen carefully. If you have to insert a new element, then start from the last element onwards and check that element is greater than this one. Yes. So shift that element here. Shift the element to the next place. Then decrement I. Now check whether A of I is greater than this 10, the element that you are inserting. Yes. Then move here. Then decrement I. Then check A of I 15, is it greater than this one? Yes. So copy A of I at A of I plus 1. Then this is vacant. So also decrement I. Also decrement I. And is this greater than this one? Yes. So move it here and erase this, remove this one and also decrement I. Is this greater than this one? 8 is greater? No. Stop. We have got the position. Where it is? I plus 1. I plus 1. Wherever you have stopped, next place to that. Wherever you have stopped, next place to that is the position for the new element X. So did I search where I should insert, then shifted, or blind simply started shifting them? No, you don't have to know where it should come. If an element is bigger, move, bigger, move, bigger, move, bigger, move. So you'll get a position directly. So you don't have to first find out where it should come. Are you getting me? You don't have to check where it should come. Simply start shifting the elements, greater elements, you will find its place. So where its place is? I plus 1. I plus 1. So now here you can copy this value 10. That's all. So can you tell me what is the code for this one? For I assign whatever the number of elements are. Let us say number of elements are n onwards, n minus 1. So number of elements are n. So what was n here? Okay, size of the array was, size of the array was 8 and the number of elements were 7. Number of elements were 7. I have kept I at where? 6. So n minus 1. अगर ये 1 से रहा तो ये minus 1, 1, 1, so problem ही नहीं रहता. So for understanding data structure and the procedure, we usually take from 1 onwards. So this is I minus 1, right? Number of elements minus 1. Then how long you continue? As long as I is greater than or equal to 0. And every time you decrement I minus minus. Then what you do? If A of I, not A of I. Okay. A of I you can write on first. नहीं, A of I नहीं लिखेंगे हम. दो भी लिख सकते हैं कंडीशन. अगर हमारा जो वैल्यू है जो इंसर्ट करना चाहते हैं वो अगर छोटा है A of I से. Is it right? Then if it is smaller than that, It should be greater, then we should stop, right? If it is smaller, then what we should do? Copy the element there. So what we should do? A of I plus 1 should be copied with A of I. Wait a minute. If the element that you are inserting is smaller than 22, so 22 we have copied, and also decrement I. Then again, 19 was x, 10 was smaller than 19, so copy it. Then 10 was smaller than 15, copy it. 10 was smaller than 12, so move it there. 10 was not smaller than 8, not smaller than 8. Then stop. So else do what? If it is not smaller, then do what? Break. Stop. This is going to happen inside for loop. This what going to happen inside for loop. Do you agree with this or not? Just check it. If you have any question, agreements, if you have any doubts, you can ask. This what going to happen inside the for loop. नंबर ऑफ एलिमेंट्स 7 थे, तो वहां से अरे का साइज इतना है। अरे अभी एक रखे तो कंफ्यूजन हो रहा है, ठीक है। 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Size of the array is 21. And how many elements we have? अब benches इतने हैं, students इतने हैं, वो है डिफरेंस। तो हम वहां इंसर्ट नहीं करेंगे ना, इधर इधर इंसर्ट नहीं करेंगे। हाँ, नहीं भैया, हमारे पास साइज ऑफ द अरे अलग है, साइज ऑफ द अरे अलग है। अरे का साइज है हमारे पास 21 और नंबर ऑफ एलिमेंट्स हमारे पास सिर्फ 7 थे, अब 8 हो गए। हम नंबर ऑफ एलिमेंट्स की बात कर रहे हैं। अब क्या क्वेश्चन है बोलो? सुनो, अगर मैं अरे ये दिखाता 2, 5, 8, 10, 12, 15. Now I want to insert 10. अब क्या बोलोगे? सर वहां जगह ही नहीं है तो कैसे इंसर्ट करोगे आप? तो जगह छोड़ू ना मैं उसमें। हाँ, तो किस में? व्हाट इज द नंबर ऑफ एलिमेंट्स? नंबर ऑफ एलिमेंट्स 5, 6th वन के लिए जगह ही नहीं है ना, तो मैं एक एक्स्ट्रा स्पेस करके बताया कि साइज इसका 6 है, नंबर ऑफ एलिमेंट्स 5 है, ये बताया मैं। नहीं सर और बड़ी रहने दो, हम धीरे धीरे करके और ऐड करेंगे, तो ठीक है और बड़ी करवा रहे। Right now you have the size of the list as 5 only. After insertion it becomes 6. So it's not necessary that whatever the capacity of the array it should be completely filled. ऐसा कोई रूल नहीं है। Understood this one? जितने एलिमेंट्स है अरे उतनी ही रहना रूल नहीं है। It can happen that you have a very big array but you have few elements in it and you will be going on adding the elements in that one. Understood? Is it clear now? So that's why I have taken just one extra space to show one insertion only. Right? So space was there. Wait, code is not yet completed. Wait, is code not yet completed? हाँ, बोलो। हाँ, अभी x लिखा ही नहीं। हाँ, after this, when you came out of this one, what we should do? A of, at which place you have to insert, and definitely you are going to insert it. Definitely you are going to insert wherever I was +1. Next place, you should insert that value x. So this is the piece of code for sorted insert. Sorted insert. And how much time this is taking? Come on. Order of n. हो गया? फिर इसका भी मिनिमम मैक्सिमम हो सकता. इफ इट इज इंसर्टेड एट द लास्ट देन ऑर्डर ऑफ वन, अदरवाइज मैक्सिमम शिफ्टिंग ऑर्डर ऑफ n. So let us take it as order of n only. For yes, you can write and break, but break is compulsory there. Over. Again, any confusion here? So this is called as sorted insert. Sorted insert. ठीक है. अच्छा, गेट में इसी टॉपिक पे क्वेश्चन है. सॉर्टेड इंसर्ट का टाइम कितना है? अभी मैं सिर्फ ट्रिकी गेट क्वेश्चन ही पूछ रहा हूं मैं. ट्रिकी गेट क्वेश्चन ही पूछ रहा हूं मैं. ठीक है. और आप आंसर गलत देने के चांसेस ज्यादा है. ठीक है, क्योंकि पूछने का तरीका ही ऐसा है कि आप गलत आंसर दो. ऐसा है, क्वेश्चन टफ नहीं है. सुनो, इफ आई एम यूजिंग बाइनरी सर्च फॉर सॉर्टेड इंसर्ट, व्हाट इज द टाइम टेकन? If I use binary search for sorted insert, कितना कितना कितना? मैं थोड़ा तेजी से पूछा मैं. हाँ, अब फिर इफ आई एम यूजिंग बाइनरी सर्च, भाई बाइनरी सर्च लेके करोगे क्या? बाइनरी सर्च लेके करोगे क्या? सर्चिंग है ना वो. तो सर्चिंग करके पोजीशन फाइंड करोगे ना, तो उसका टाइम कितना हो गया? लॉग एन. लेकिन शिफ्टिंग तो करना ही पड़ेगा ना फिर से, तो उसका टाइम कितना हो गया? ओ ऑफ एन. ओ ऑफ एन नहीं. अरे भाई सुनो, लॉग एन उसके बाद शिफ्टिंग एन. एन हो गया. सुनो सुनो, इट्स नॉट कंप्लीट. इट्स नॉट कंप्लीट. तो प्लस है वो, इट्स नॉट इनटू. इट्स नॉट इनटू. फर्स्ट सर्च, ओके, यहां पे इंसर्ट करना है, शिफ्टिंग करो. पहले तो हमारे पास जो कोड है दैट डजंट नीड सर्चिंग एट ऑल. तो गेट में बोला वो कि लॉग एन बाइनरी सर्च अगर मैं दूंगा तो सॉर्टेड इंसर्ट को कितना टाइम लगाओगे? वी विल टेक ऑर्डर ऑफ एन ओनली. यू कीप योर बाइनरी सर्च विथ यू ओनली. वी डोंट नीड इट. वी डोंट नीड इट. वी डोंट हैव टू सर्च एट ऑल. On this idea only, we don't have to search. ये point पहले मैं वही समझाया. First I ask you, what you will do? You will find a position. Then after that, you have to shift. So when you have to obviously shift them, definitely shift them. Why do you search? Shifting itself will tell you where the position is. So you don't have to search at all for sorted insert. So do you understand this point or not? Do you realize this point or not? On that basis only they have asked the question that if binary search is used for sorted insert, he has not asked for sorted insert, he asked for insertion sort. तो वहां पे आंसर लोग क्या बोलेंगे? n स्क्वायर नहीं बोलेंगे, n log n बोलेंगे. नहीं होगा, n log n नहीं होगा, n स्क्वायर ही रहेगा. शिफ्टिंग का n शिफ्टिंग्स, n स्क्वायर है उसका. अभी वो नहीं देखे ना हम. एनीवे, तो मैं इसको मॉडिफाई कर दिया, सॉर्टेड इंसर्ट कर दिया मैं. गेट क्वेश्चन एक्चुअल गेट क्वेश्चन नहीं है, थोड़ा सा मॉडिफाई. तो व्हाट इज द टाइम टेकन फॉर सॉर्टेड इंसर्ट इफ आई एम गिविंग बाइनरी सर्च टू यू? तो ऑर्डर ऑफ n ओनली. वी डोंट नीड बाइनरी सर्च एट ऑल. दिस लॉजिक डजंट नीड. हम सर्च करके इंसर्ट कर रहे थे तो अरे भाई ठीक है आपने बाइनरी सर्च दे दिया, बहुत अच्छी बात है बोल देते. हम तो सर्च ही नहीं कर रहे हैं, तो इट्स यूजलेस. We will not search at all. आ गया, समझ में आ गया? तो one gate question we came across in this one. So we have learned is sorted, we have learned sorted insert. Next is insertion sort. We'll see that tomorrow. You can leave quickly if you have to go for dinner. Dinner जाना है आप. Okay, online students, we are stopping here. Any questions? Which sort can be divided and try add based on middle what discuss? Okay, nahi, some question somebody. Then sorted can be divided and try to add based on middle what we did. Nahi, sorted. No, Muni, we cannot use binary search. Okay, hope you have got it. We are ending our session here.